Welcome. So 9.3, circumference area, arc length, and sector area. Okay, so this first page is pretty much what you've done before. A circumference, sometimes we write it as C. So a circumference is equal to 2 pi r. Okay, and where r is your radius and C is your circumference. Okay, area. Oftentimes we write that as A. A equals pi r squared, all right, where r is your radius. So we're just going to go over this really quick. I would pause and see if you can remember how to do these problems. And if not, then you can just watch, okay? All right, so it says find the circumference of the circle. List your answer in both exact form using pi, so you want to leave pi in your answer, and approximate form. So if you multiplied that all with pi, you would end up getting an approximate form. So for example, for A, circumference is 2 pi r, where r in this problem is 8 centimeters. Okay, we would simplify that. That would give us 16 pi centimeters, and that would be our exact circumference. Okay, if we wanted to have an approximate, we would multiply 16 times pi. All right, and most calculators have pi on there, so all you need to do is plug in 16 times pi. All right, and for this, that gives us 50.27 centimeters. If you can, please write your answers in hundredths place. So we'll have two numbers after our decimal. Okay. Let's do another one with B. This time they give us a diameter. So if that's the diameter, what is the radius? So it's just going to be 10 centimeters. So we'll do the same thing. Our circumference is going to be 2 times pi times the radius, which is 10 centimeters. Okay, our exact answer would be 20 pi centimeters, or approximate would be to multiply those together, and that would give us 62.83 centimeters. All right. Okay, let's go to C. So find this. Find the circumference if r equals 7, all right, so we don't have the graph, but you'll do it exactly the same. C equals 2 pi times r, which is 7. So the exact would be 14 pi, and approximately would be 43.98. Again, find D and R and round to the nearest. Find D and R to the nearest hundredth. Okay, so here they give us the circumference, and we want to find the radius and the diameter. Okay, so we'll use the same formula. Our circumference is equal to 2 pi r. So we're going to want to find what r is. So we can divide both sides by 2 pi. You put that in your calculator, and you would get r equals 21.79. Okay, remember, round to the hundredths place. And then to find the diameter, you're just going to do 2 times your radius, which will give us 43.58. Okay, so that shouldn't be too bad. We've done that before this year. Okay, area, just a reminder, it's on the top, but I'll just have it right here. Area equals pi r squared. So for this one, pi r squared, our area would be pi times 10 squared, or 10 feet squared, I guess I should say. Okay, so exact would be 100 pi feet squared. Okay, and approximately, you would just multiply that 100 and pi. That would give us 314.16 feet squared. All right, again, they give us the diameter. The radius is going to be 7 kilometers. All right, so we'll do the same thing. Area is pi r squared, so 7 kilometers squared. So exact will be 49 pi kilometers squared, and approximately, we just multiply the 49 and the pi, that would give us 153.94 kilometers squared. Okay, find the area if D equals 15. All right, so remember when we're solving for an area, we need to do the radius. So radius is half of the diameter. So we'd do the area equals pi r squared. Okay, and to get r, we'll do the 15 divided by 2, the diameter squared, or divided by 2, gives us the radius, and we'll square that. All right, and actually let me put this in my calculator real quick. So 15 divided by 2, 15 divided by 2, and then we'll square it. All right, so that would give us an exact answer would be 225 divided by 4 pi. Okay, it doesn't have units, so we wouldn't need to write feet squared or anything. And if we did exact, or that is exact, if we wanted to do approximately, we would write it as a decimal. Okay, and we times it by 2 times by pi. And that would give you 176.71, and that would be our approximately. All right, D, find the area if the circumference is 14.9. So we would need to first find what the radius is. So we know that circumference, which is 14.9, equals 2 pi r. We're going to need to solve for r. Divide both sides by 2 pi. All right, and you'll end up getting, those would cancel, and we'd get r equals 14.9 over 2 pi. All right, and you could have that as a decimal if you wanted to, but I would keep it exactly how we, so this is still exact. So we would just plug that into our formula for our area. Area equals pi r squared. Okay, and r, we just found out, is 14.9 over 2 pi squared. And then from there, you could plug that in your calculator. Let's see, would get, did I do that already? I did already do that. Okay, so if you did simplify this, I think that turns out to give you 2.37. Okay, but if you wanted to keep it as close as possible, okay, and then would plug that in, I think that gives you 17.65 approximately, okay? All right, so that would be your area. All right, okay, so let's look at this. Consider the following circles. So our first one for A says, what proportion of the circle are you supposed to be using, that are you be using solving for? That doesn't make any sense. What portion of the circle are you supposed to be using? Okay. Yeah, that is really bad wording. Okay. So what we're asking for is, what percentage of this circle are we using? That's a better way to say that. What percentage of this circle, this whole circle, what percentage of that are we trying to find? Okay, and you would look at that and you may say, we're supposed to be using a fourth. Okay, so we're using, it looks like 1/4 of our whole circle. And how can you get that? How do you know that it's 1/4? Okay, well you may say, well, 90 degrees, what we have, the total circle is 360. So that gives us 1/4. All right. Looking at this one, you'll do the same kind of thing. What portion of the circle are you using, or are you supposed to solve for? Okay, so here you may say 5/8. Okay, but how do you know? You would do 225 and divide it by 360, and that will give you a percentage of that circle. So here we'd get 5/8. Okay, I guess that's not a percentage, it's just the ratio. All right, so this is part of your circle divided by the whole circle. Okay, this is what we're going to be wanting to use. So this is basically what we're adding on top of what you already knew. Okay? So, for example, if they want us to find an arc length, so it's basically part of the circumference, what percentage of that circumference are we going to be using? Okay, so how we're going to do that is we're going to say the arc divided by 360, okay, and that will give us our percentage of our circle, and then we're just going to multiply it by our whole circumference. So we'll multiply that by 2 pi r, and that will give us our arc length. So for example, this one, if we did 270 divided by 360, that will give us 3/4. So 3/4 of a circle we used, okay? So we'll be doing 3/4 times 2 pi r. Okay? And then you would want to write that as an exact form. All right? So on the test, they'll be wanting to have your answer including pi. So don't use decimals, just simplify it. The best way to come up with that is to just put pi on itself, like by itself, okay? And we can just calculate what is 3/4 times 2 times 8. And then we'll just have pi at the end, yards. Okay, so let's calculate this part, and that will end up giving you 12 pi yards. Okay, and that would be our arc length. And then they also ask, what is the sector area? So the sector area is the percentage of the area of a circle. So you'll do the same type of thing. You'll do arc divided by 360, what arc that you want to use, multiply it by pi r squared. Okay? All right, so for this A that we're working on, we have the same percentage that we're going to be using before, so it would be like 270 divided by 360, which is still 3/4. So we're looking here for the sector area. So we have this percentage, 75% of the circle is what we're going to be wanting to find. Okay, and then we'll multiply it by pi r squared. All right, so you still want to keep that pi separate. So what we're going to do is we're going to multiply this 3/4 by 8 squared, and that would end up giving us 48 pi yards squared. Okay, so pause and see if you can come up with B, C, and D, and then we'll talk about E and F at the end. All right, so here we go. We want to find the arc length. so the arc length, okay, and we're going to want to find the percentage of the circle. I mean, you could just look at this and say, oh, well, that is 3/4, okay, and that'd be fine. Or you could also do 270 divided by 360, okay, I'll give you the same thing. So we'll multiply that by the 2 pi r, okay, and we could simplify that. You just multiply all the number things and leave pi by itself, and you'll end up getting 27½ pi feet. And again, please don't have any decimals. If you have decimals, you may have to, I mean, the problem is, you know, the test is going to be multiple choice. So you're going to be looking for some sort of A, B, C, D that will look something like this. So if you have it written as a decimal, it may be hard to find your right answer. Okay? All right, so if just, I guess maybe I'll go over this just really quick. So 27 over 36, we already found that that's 3/4. We'll multiply that by 2, and we will multiply that by 9, and then we still have this pi. So when we multiply what I just wrote in the parenthesis, if you want to simplify those, that would give us 2 on the bottom, and we end up getting 27 divided by 2. Okay, so you're welcome to just plug that in your calculator. Oftentimes calculators can switch it between decimal to fraction. All right, and that could be really useful. All right, and then we also want to find the sector area. Okay, so here we'll do the same thing. This is 3/4 of a circle that we're trying to find here. So 3/4 times our area, which is pi times r squared, which is 9 feet squared. All right, and then we could simplify that. What's 9 squared? Well, that's 81. So we have 3/4 times 81 feet squared, and then we still have this pi. So usually I'd probably put this pi in the front. Okay, it would multiply that, and you'd end up getting 243/4 pi feet squared. All right, so again, just evaluate this, and you want to leave it as a fraction. Okay, let's see, C. We'll do the same type of thing. So here it's not so easy to see that it's 2/3. So you'd probably want to use the formula that we had at the top. So if we're trying to find, I'm just going to put a line there. If you want to find this arc length, we'll want to find out what this ratio of the circle is. So 300 divided by 360 times the circumference. So circumference is 2 pi r. Okay, keep our units in there. All right, and then I would simplify that and have all my numbers on one side. 300 over 360 times 2 pi feet. Okay, and then I would just plug that into my calculator and make sure it's written as a fraction. Okay, once you do that, you end up getting 10/3 pi feet. All right, and we'll do the same thing with the sector area. So we'll do 300 divided by 360, and we'll multiply it by its area, which is pi r squared. All right, you'll do the same sort of thing. We'll have all of our numbers at one side. So 300 over 360 times 2 squared, which is 4. And then we have pi, and we have feet squared. Okay, so we kind of distribute that square to both of those. All right, and we'll end up calculating that, and what do you know? It ends up giving you the same thing, 10/3 pi, but this time it's feet squared. Okay, next one, same thing. So arc length. This time it's 120 degrees. 120 divided by 360. That will give us our portion of our whole circle. We'll multiply it by our circumference, 6 and 2 pi times the radius, which is 16 miles. Okay, and you'll do the same thing. You'll end up getting 32 thirds pi miles. And then with the sector area, same thing. So our portion of our circle that we'll want, times it by the area, which is pi r squared. Okay, and you'll just want to multiply all of the numbers. So 120 divided by 360 times 16 squared. Okay, and then we'll still have our pi and our miles squared, and that will end up giving us 256 divided by 3 pi miles squared. Okay, so looking at E and F, it's kind of written a little different.
Holly Larson to the
Holly
main
Larson.
office. Holly Larson to the main
All right,
office.
Holly Larson, here we go. All right, it's a little different, but here they give us the angle in radians, okay? So radians is a different way to write an angle, all right? So, and the relationship between the degrees, 360 degrees for a circle, is the same thing as 2 pi, all right? So we will do the exact same thing, except if we are doing angles, we'll do the arc divided by 2 pi.
Max Troy to the main office. Max
Sorry
Troy
about
to the
that.
main office.
So yes, I am doing this during lunch and people are talking. So we'll do the same thing for the sector area and the arc length. So we'll just be dividing it by 2 pi whenever they give you the arc as radians instead of degrees. Okay, so we'll look up here and we'll say, okay, arc length. We want to find that ratio, how much percentage of that circle we're doing. So we'll do 5 pi thirds out of the whole thing is 2 pi. And then we'll multiply it by our circumference, which is 2 pi r, which is 14 yards. All right. And then at this point, this will always be a percentage. These pi's will cancel out. Okay, so if you did plug this all in, those pi's would cancel out and we wouldn't have to worry about it. So if we want to have everything, these will always cancel out, like I said. You can rewrite this as 5 thirds, all divided by 2, times 2, times 14. That would be all our numbers that we're wanting to multiply. Then we'd have our pi. This comes from there, this comes from there. And then we still have our yards out here. Okay? You would calculate that, put that in your calculator, have it as a fraction. You'd end up getting 70 thirds pi yards. Okay? And then we also want to do it with the sector area. So we'll do the same thing, 5 pi thirds divided by 2 pi. Those pi's will cancel. And then we'll multiply it by pi r squared. Okay, we'll multiply all the numbers together. We'll end up getting something kind of crazy. It'll be 490 divided by 3 pi yards squared. Okay, so let me bring that down to simplify that a little bit, or talk about what's in between those two. So how we did here is 5 divided by 3. And one time, if we write it as 2, you can write that as 2 over 1. You can always make the reciprocal. I think that was last year what you learned. before, so you could also write that as 2 divided by 1. Okay, and you could multiply it that way. But either way, if you plug it in your calculator, it should get it in the right order. It will divide 5 divided by 2, or 5 divided by 3 first, and then it will divide by 2. Okay, and then we have 14 squared. That's what gives us this 490 divided by 3. All right, and then we still have our pi and yards squared. All right, and we'll do one more example. Okay, let's see. Same thing, we want to find our arc length, which is the percentage of our whole thing. So that would be pi thirds divided by 2 pi. Okay, times the circumference, which is 2 pi r. Okay, and then again, you can cancel out those. You'll end up getting 1/6 times 2 pi times 14 centimeters. Okay, and you can plug that all in your calculator. You'd end up getting 14 thirds pi centimeters. That would be our arc length. Okay, and then the sector area would do the same thing. What we found here was 1/6, so we could still just write that 1/6 times the area, which is pi r squared. Okay, and take care of all those numbers, would end up getting 128 thirds times pi centimeters squared. All right, so you may have problems on...
Max Ochoa is the main office. Max Ochoa is the main office.
Yep, so you may have problems either way on the test. You could have ones where they give you degrees, like A, where they give you a degree, or they may also give you radians. Okay, so feel comfortable to be able to do both. All right, and yeah, okay, and that's pretty much it for circumference area, arc length, and sector area. I think there are 2 problems perhaps around that number on the test, so feel comfortable how to do those. All right, remember the test is going to be that Monday and Tuesday. We'll review a little bit from each of those 3 sections, and then we will take the test. Let's look at the homework really quick. So the homework right here, 9.3, the whole back page is just a review. So I want you to do all of those. And these aren't too hard to do. I did half of them are degrees, and then the other half are radians. So you can feel comfortable doing both of those. So I would like you to have all of these done. You should have already had your project done already, so you'll just have time to do these 8 problems and then review using this review, okay? So one thing that maybe I'll just talk about that really quick too. So there's different types of angles. Let's make sure we feel comfortable about how to do all of those, okay? First thing we learned was central angles. So 15 through 16, those are central angles. Okay, we may want to realize that a circle adds up to give us is equal to 360 degrees. A semicircle is 180. Sometimes we like to use that whenever we have a diameter. We also know with central angles that the angle is equal to the arc. So like for example here we have an arc, sometimes we have some angles, okay? We need to feel comfortable that they're all the same whenever it's a central angle. Not the case for any other type of angle, okay? After that we learned about inscribed angles, so these are inscribed, okay? And what we learned from there is we know that whenever they give us an angle, an inscribed angle, the vertex is on the circle, that's when it's an inscribed angle. We know that the angle, or the arc, I should say, the arc is equal to 2 times the angle. All right, so feel comfortable, know how to do that when we're given an angle. Okay, here was an angle, here's an angle. We'll want to use that when we come up with these arcs. And don't forget that what they're asking for. I had people on the quiz, they solved for the arc, but they did not solve for the question marks. All right, and then this is what we learned last time. These are circumscribed angles. Well, I guess not all of them, only 2 of them. So these two, 11 and 12, these are circumscribed, meaning that the circle or the vertex is outside of the circle. Okay, so one more time. Central angles is at the center. Inscribed angles are on the circle. Okay, here and here. And circumscribed angles, the vertex is outside of the circle. All right, and for those, we want to use the equation that the angle, so like this angle, is equal to the major arc minus the minor arc. Okay, and if you don't remember that, you may want to review the video, okay, or talk to a neighbor. And then the top 2, these are both inscribed, so we've already talked about that. Don't worry that if our line, we're using a tangent. This is still going to be a inscribed angle because the vertex is on the circle. Okay, so you're going to use the same relationship as we do all of the other ones. Okay, and that covers everything. Please do your homework on time so that you are ready for the test, because we're going to talk about that a little bit on Monday and Tuesday and then take the test. So this is our review, basically 9.3. We're going to cover the sector area and arc length and the 3 types of angles on the circles. All right, if you have any questions, please let me know. And if you already watched this and you haven't done